spinning? Let's do a demonstration to shed a little light on these concepts. Okay, you're gonna need a globe and a table lamp without a shade, plus a table to put them both on. Put the lamp in the center of the table and turn it on. Put the globe on one side of the table. Now hit the lights. The globe is Earth. Makes sense, right? The lamp at the center of the table is the sun at the center of the solar system. Now slowly spin the globe. As the Earth rotates, the sun lights up one side of the planet better than the other. It's day where the light is shining more brightly on the globe and night where it's not. Now let's see what the Earth's revolution around the sun looks like. Give the globe a few spins with one hand while slowly pushing the globe in a circle around the sun, or the lamp with your other hand. So, do you notice how the Earth keeps rotating as it revolves around the sun? If this were the real sun and Earth, by the time you get back to where you started, the globe would have completed 365 rotations or days. And that's another year gone by. So, what does all this show us? It shows that what looks to us to be the motion of the sun in the sky is really caused by the motion of the Earth. So now you know, when you look up and see the sun setting or rising, it's not going around us. It's sitting pretty much at the center of the solar system, while we and the 7 other planets go around it. That sun, always gotta be the center of attention.
Awesome. What a good video. It's probably
I forgot to hit record. Oh, you hit record. Good job.
I did. Yeah.
Okay. Cool.
So that was a really cool video. And I was gonna try and show on here. So if you can see the light, I might need to shut the blinds a little bit. Try this real quick.
You're a little frozen, Miss Lambo.
Yeah, that's what I was trying to say. It's really hard. It's like not picking up everything.
Yeah. Nathaniel's not frozen, and Rajni and Madison aren't frozen, but you seem to be. For some reason.
Frozen. Am I still not moving? Okay.
You are moving.
Right? Awesome. Why don't we'll just go ahead and jump into the PowerPoint and finish that off, and then we'll share our demonstrations. But I love that video. The reason why I love it so much is because it's so hard, guys, to picture the solar system that we're in, because we literally have the sun in the middle, right? And then here we are, Earth, and the 7 other planets, and we're literally rotating and orbiting and revolving around it. But while we're revolving, we are also rotating, right? So we're doing a lot. And notice, have I moved the red ball once? No, right? So our sun is not moving. Although when we look in the sky, we're like, oh, here comes the sun, right? And then it comes up for the day, and then it goes down for the day. Well, really what's happening is the way that we are seeing it, the way that we are turning, and I always use this eyeball as a reference. So as we are turning towards it, now I'm starting to see the sun more, and now it's starting to go away because now I'm seeing the other side of the Earth, right? So as I'm moving away from the sun, now the other side of the Earth is facing the sun, and I over here with my eyeball have no sun, meaning that it is nighttime. So it's really hard to kind of picture that all in your mind, because one, you have to have 3 hands, and then you have to have the Earth and the moon revolving around Earth while it's too many hands. It's a circus trick, right? But yes, and that was a great representation, Mr. Pierce. So thank you for sharing that video. So let's go ahead and jump right in here and just let me know, because I can't see if it pauses or if we need to stop or anything of that sort.
Okay, you're a little frozen again. All right.
What, Mr. Pierce?
I said you were a little frozen again. But if you're going to your desktop, that might help. There we go. You guys and girls see that? Miss Hare Lambo, I think you're muted.
Can you hear me now?
Yeah.
Woohoo! All right. So our essential question is talking about how does the movement of the Earth affect the star patterns that we actually see in our sky? So Tuesday we talked about having you guys go out at nighttime and just look at the stars and notice what you're seeing. So throughout the week, I want you just to go and look outside. I'm not asking you to go run around. I'm just asking you to look outside at the stars from a window even and notice what you're seeing.
That. So, okay, well, what we'll do, here comes Aunt Mariah, guys. I think she's about to come on. So.
We lost you again.
Now, if anybody else joins us, I'll do that for a minute, but. Okay, ready?
When men come, say. I'm back.
Well, we must be having some technical difficulties. I'm going to get my PowerPoint ready just in case. So I'll be right back.
You see me? Maybe. Just look at this. Is that better?
Yeah.
Me?
Miss.
Do you just see me now? Yes, ma'am. Okay. Ready?
Your.
They wanted to get rid of me.
Oh, you got kicked off?
I think so.
Okay. Yeah, that was happened to me last week, but it hasn't happened this week. But the first week it really was. I was bringing up my PowerPoint just in case we lose you again. I'll just keep going.
What?
Yeah.
Let's be.
Okay.
We keep
Why?
I can't hear anything.
I can hear you.
Okay. Miss Hare Lambo, I'll just I'll try to bring mine up. Okay. I don't know if that's okay or let me try that.
It doesn't matter. Yeah, whatever you want to do.
Okay. And then if your audio's working or not.
You see your screen right now?
Yeah, and we can see you at the bottom and hear you at the bottom too. Now I see both of you.
Excuse me, Mr. Pierce.
Yeah.
Do we actually have any assignments?
Today is just this lesson, and then tomorrow you're gonna have kind of like an assignment to answer.
Quiz.
We're gonna look at what you did yesterday, your diagrams. So, okay. So, can you all see this?
Yes, sir.
All right. I'm just gonna trying to.
While Mr. Pierce is loading this, how many of you actually drew your sun and Earth model? Did anybody complete that?
I do.
You did, Madison?
Yes, ma'am.
And Tavaria? Good. Okay. So I want to make sure that we leave time for that because I definitely want to see your guys' models.
Hello? Can anyone hear me?
Yeah.
Yep, we can
Yes.
see you.
Oh, thank you. Sorry, I almost missed my lesson. My bad.
It's okay. It's recorded too, Jeremy, so you can always go back and look at it, okay?
Oh, okay. Thank you. Thank God.
You're welcome.
And one thing, you guys forgot to send me a text, so I didn't know what time it was going to start.
I did.
10:30 Tuesday and Thursday. Write it on your guys' calendar. We're keeping every Tuesday and Thursday at 10:30. No matter
okay.
what, we're going to be here, okay?
Okay. Thank you.
You're welcome. Hang on. Awesome, Mr. Pierce.
Am I going to the right place?
Yep, you're doing awesome.
Okay,
Go ahead,
there
one
we
more.
go.
All right. So different times of the year, different patterns of stars can be seen in the night sky. If you just jumped on, we're talking about the stars and what we can actually see. I don't think you guys can see me and the slideshow at the same time. I don't know if you can or not.
Now I can.
You can, yay! Okay, so we see different star patterns depending on where we're at. So once again, the sun does not move. Here's the sun, doesn't move, stays in the same spot. But what does move is us, Earth. So if I am at nighttime, my little eyeball, remember that's us. So if I am facing away from the sun and it's nighttime, there are different star patterns on this side than there are on this side of the sun. Why? Because the sky does not move. So if we're sitting over here, we're going to see all the star patterns in this part of the sky. But when we start to move and revolve, now we're going to see the star patterns in front of us this way. As we keep revolving, now I'm going to see the star patterns out this way. As I keep, now I'm going to see the star patterns this way. So why, if I'm on this side of the sun, why can I not see star patterns on that side of the sun? Why would I not be able to see them? Right? That's what I want you to think about. What would you say? Okay. Go ahead, Mr. Pierce.
Okay.
Like it said, show all of them are hiding. I don't want to hide them. Okay, well that's from Miss Kim. I'll figure it out, guys. I'll figure it out, and then once I figure it out, are there any questions that you guys have about your math? What about laps? You have all week to do
It's almost
one
like
lap, and it's all. And Miss Walsh
we
tells
could
you
hear
what
Miss
to do.
Kim, I think.
Piece of paper and a pencil. Did anybody
Miss
do the lap?
Parker.
There we go. All right, guys, please mute your mics. I know you guys have other people in your house, so please go ahead and mute your mics.
Yeah. I thought it was
What?
jumbling up the audio from her team or something, but yeah, that's from, yeah.
Somebody else learning, yeah.
Yeah.
Okay, so this is exactly what we were just talking about. So if you can see, we have different constellations during different times. We have summer, fall, winter, spring. So they are our seasons, right? So once again, if here's the sun and here I am on Earth, and here's summer, here's fall, here's winter, here's spring. I'm going to see different stars at different times of the year, just because of the way that I am revolving and going around the sun. Why? My sky does not move. Yeah, you see it? Why? Because my sun does not move. Okay, go ahead, Ms. Pierce.
I can see the Big Dipper.
Yeah. Now there are some constellations that are straight up, like above the Earth, like some stars that you always look above the Earth. So there are a few constellations you can see year round, like the Big Dipper, the Little Dipper. But again, they still look like they're in different spots, though, because of where we are around the sun.
Absolutely. This is what we were just talking about, guys. If the sun is here in the middle and here I am on Earth, why can I not see stars on the other side of the sun? If I'm over here, what is causing me not to be able to see the stars on the other side of the sun? Well, so what? What's in the way?
I was trying to highlight over here in the bottom left corner. Read that.
The
You wanna read that?
sun in the way, not
Yeah, look how big the sun is compared to our Earth. And this is just a model,
turn off the music.
right?
So I'm not playing.
We know, right? So we know that the sun is actually way bigger than this. And we know the Earth is way bigger than this, right?
Hey,
I cannot
My camera.
see stars on the other side.
I'm going to see my face.
So big, it's going to block it. The sun is only part of the system.
You glitching out.
One. The only part on all the other planets are part of the solar system. Galaxy.
I'm gonna try one of these questions where our audio. That would be,
It's a group chat. It is work. It's a group chat. It's a science group chat. Shush.
all right, Anaya, read this question. Anaya, read this question out loud.
What is the reason Ursa
Major.
Major is visible at night during some months, but not others?
All right, so up here in the left top right corner is Ursa Major. It is a constellation, which is kind of like stories made up. Those lines are not there, but if you connect the dots of the stars, you look like you can see a big bear, Ursa Major, the big bear. But we can see Ursa Major during the summer, but not the winter. What is that reason why we can't see Ursa Major in the winter?
I'll give you a hint. Here's the sun. Here's Earth in summer. Here's Earth in the winter.
Thank you. Because we're facing the sun?
We're on the other side of the sun, like we revolve all the way around it, right? You wouldn't be able to see. I'll go back. So if Ursa Major is over where number 4 is, the Earth right now wouldn't be able to see on the other side of the sun. It would be too bright because at nighttime, we would be facing number 1. So sometimes you can't see all of the stars depending on what month it is.
Right. Yep. Mr. Pierce, you want to jump into our models and see what the kids did with that?
Absolutely. All right.
Okay, so I know Latrell said that, or Madison said he has done his, and I know Tavaria has done hers. I'll kind of give you guys an example so that you can show yours and it kind of explain it. So here is my model. In the middle, I have the sun. With the sun, you know what? Can you mute everybody?
Sure.
Just for a minute, please. I appreciate y'all.
Okay. Wait, who's not muted? Naya, we got to mute you for a second.
All right. So,
I don't know who's not muted. It looks like everybody is. Okay, who has their model to show up on the screen, like holding it up until she gets back on? Like, yeah, hold it up. All right, that's awesome. I see the sun in the middle and the earth. Look where the earth is, everybody. Look at Madison's. What is it called when the earth travels all the way around the sun?
Revolution.
Revolve. Good.
Revolve.
And how many days does that take?
365.
65.
Absolutely. Good. Good. What does yours say down at the bottom, Madison? Hold yours up a little higher or read it to us.
It takes 1 year or revolve to go around the sun.
That's amazing. We
let
really
me
like
see it, Madison. I didn't get to see it. Beautiful. Can your mom take a picture of that and send it to Mr. Pierce on Dojo?
I'll ask her.
Okay, that'd be awesome.
All right, Tavaria, can you hold yours up a little bit closer to the camera? We have like a little glare. Down a little bit. Oh man, I like that you have the axis. Everybody look at her tilted axis.
I can't see it.
Who remembers what's, Nathaniel, can you put that down for a second? Who remembers what happens because Earth is tilted over a little bit? Well, think of it this way. If you open the oven when you're baking something and you lean toward it, what are you going to feel?
Hotness.
Hot. So if your part of the earth is leaned toward the sun, what season's it going to be?
Summer or spring.
And if you lean away, if your part of the earth is leaned away from the sun, what is it going to be?
Winter, autumn.
Cool.
Winter. Or maybe autumn or spring if it's kind of a little bit.
Winter, spring, summer, and fall.
I love that diagram, Tavaria.
Winter, spring, summer, and fall.
Tavaria, send it to me
Jeremy.
too. Madison, try and send it to me too. I want to see them all. I can't see them. Or Mr. Pierce can send them.
Muted you.
Did anybody else have a model?
I did.
No, I don't have any paper.
Well, you got to get some paper, mister.
Go get a cardboard box and draw on that.
I need to draw a diagram of the solar system.
Not the solar system, just the earth and the sun.
I don't think it's lunchtime, Nathaniel.
Almost.
Please, just one pencil. I don't care if it.
All right, I'm starting to see we have a lot more people on here, so some of you are gonna have to re-watch this video later when we post it because you missed a lot of it. Okay.
Oh, see.
Pierce.
All right. Is there anything else?
Do I
Anybody else have a video? I mean, a diagram.
Pluto?
I
No.
did it.
No, Jeremy.
Okay.
Go to the science page and read what the. Oh, there's one.
I can't see them. Where
It's a
is
lot of
it?
color.
I love that one. That is very good. All right, Franny.
Yeah.
What makes day and night? We just talked about the season, so you can do day and night.
The sun.
And then the earth does what?
Rotate.
Rotates. That's right. That's the
Rotation.
next thing we were going to talk about.
Sleep.
How long does it take the earth to rotate to make day and night? All of the whole day.
24 hours.
You got it, Madison. So that's rotation, and revolve is the year or the seasons. That's all right. Anybody else out there have a diagram? And you're
Oh,
welcome
now I can
to
see you
take
all.
pictures of them and send them to us.
Mr. Pierce,
Yes.
when are we gonna start our home? Like, when do we go back to school?
Right now we've heard it's gonna be at home until May, at least May 1st. We haven't heard. We haven't heard for exact day yet, but it could be even longer. We don't know yet. Just depends on how Jacksonville does. If enough people stay at home and the disease stops spreading, or the virus, I should say. If enough people stay at home, maybe we can go back in May.
Okay.
Nobody stay inside.
All right, guys, I think you did an amazing job. If you haven't done your diagram, you're more than welcome to finish it and post it on our Teams page or in Dojo. And we're
Mr. Pierce, you're muted.
Somebody had muted you.
Who muted me?
Somebody's laughing.
So tomorrow, be on the lookout for some questions on the assignments, okay?
Okay.
To
I
see
didn't mute
what
you
you've
this time.
learned this week.
This time I did not mute you. Not me this time. Was it me?
All right, well, have a good lunch and do your science IXL this afternoon.
Okay.
Oh, Kurt, I have a video. It's not that long. It's pretty funny to help you. Okay?
Okay.
Thursday video. Watch it, then do your math.
Bye.
Bye, guys.
All right. Peace.
Yeesh.
All right. See you all later.